Okay, so guys, this is a small copy video. Hopefully, this won't take too long. Today, I'm gonna talk about for loops. Okay, so y'all are familiar with the basic for loops we did in the last semester, and I'm gonna build on top of that and give you guys some tips and tricks and a little bit more advanced stuff about for loops. So let's get started. So you guys can see this, right? Yes, you can. Uh, Yes. So over here I have a small for loop here. Okay, so what it does is that it uh, goes up, it checks for the, it's going to start from 0 and go up until 2 and then print the value and then that's it. Let's return 0. Give me a minute. And then let's compile this and then let's execute the program, and as you can see it gives the values 0, 1 and 2. So it starts as 0, prints the value, then it prints 1 and then 2 and then 1. Once it gets to 3 it's no longer less than 3, so the program gets terminated. Okay, so yeah, you guys know about those. So let's talk about some stuff that uh that Virat sir didn't cover in his lecture. So these are stuff we will need for the DSA stuff. So if we take a look at the for loop, inside the brackets, there are three sections separated by this semicolon. Okay, so over here we have one section, then here another section, then here is the third section. Okay, so these sections are this one is known as the initialize section, the condition section, and the update section. So how a for loop works is that when you execute a for loop, first of all, this section gets executed. So what we do, we declare a variable called I, then initialize the value 0 to it. Okay, that's the first step of a for loop. And then it checks for the condition. If the condition is evaluated to be true, so in this case, it will be because 0 is less than 3, the body gets executed, and if the body part is executed, the update this update gets executed. So what happens over here? The iterator gets initialized. Okay, so we call this the for loop control sometimes. I gets initialized, declared and initialized. Both happens in one step here. And it checks for the condition. If the condition is true, the body gets executed. And if the body got executed, the update part gets executed. That's how the for loop works. Okay, so if we take a look at the number of operations it would take for us to execute this for loop. So when we execute this for loop, this part gets executed. So that's 1. And this parts get executed. So this part got executed once, then this part gets executed, also 1, then this part gets executed. Once one loop is done, one iteration is done, it goes back to the condition and check whether is it true or false. And now it started at 0, got updated by one value. Now its value is 1. That means this condition gets evaluated to be true. The body gets executed and the iteration runs again. Now the value is 2. Started at 0, it got updated once, got updated twice. Now the value is 2. The condition is checked again. It's true. So the uh, body gets executed and the update gets executed, and now the value is 3, and then it runs the condition again, and now this part evaluates to be false. That means the for loop terminates. So if we count the number of operations it took, this one took once, this one was executed once, this one got executed 4 times, 3 times it was evaluated to be true, and 1 time it was evaluated to be false. The body got executed 3 times because this condition was evaluated to be true 3 times, and because body got executed 3 times, the update uh, part got executed 3 times. So if we try to generalize this, okay, let's say there's an integer called n, and let's set that value to 3, and let's replace 3 with n. Okay, so if we try to like generalize this, we say this initialized part got executed once, and then this condition got executed n plus 1 times. That one extra one time comes when the condition is evaluated to be false. That's when the for loop terminates, and then this one and the body will get executed n times. So that's how a for loop works. All right, so just keep that in your mind. That's how a for loop works. So over here, as I said, we have 3 sections. One thing about for loops in C and some other programming languages is that you don't have to put all of this inside these brackets. So let's say some of you might have done something like similar to this. So some of you might have declared the variable outside the loop and then done something like this where you initialize the value inside the loop and then execute the for loop. So this also works. If we try to compile this and execute, it gives us the same output. But there's also another way you can do this. Instead of initializing the value inside the for loop, you can initialize it outside and then leave this part empty. So right now, if you take a look at this one, okay, over here, the initialize section is empty because it's done outside the loop, and that's completely fine because the for loop will behave the same way. So if we like compile this and execute, we get the same output here. Okay, so you can put the initialize part outside the for loop. You can put the update part outside the for loop as well. So let's uh, put it here. Okay, so now if we take a look at this one, so what happens is the value gets initialized. Over here, initialize part is empty, so it does nothing. It checks for this condition, then it executes this body, and then the update part is also inside the body. Because of that, we don't have to include anything over here. So it gets updated within the body, and then it checks for the condition again. Because this is empty, nothing will get executed, and then it checks for the condition again and keeps executing. Let's check this whether this works. Okay, it should be gcc main.c, and then let's execute again. We get the same output. So the other thing, we don't need this one either. We can remove that, and then we can put it here. If I is less than n, what we are going to do, we're going to execute this part. If it's greater than n, which means our break condition, we are going to break the loop. Okay, so you can create the for loop like this as well. So if you take a look at this, so this one is known as an infinite for loop because we don't have a break condition. The break condition is implemented inside the body, so we don't have anything inside the parentheses, inside the brackets. So we initialize the value outside the loop, and then this one gets executed, but there's nothing, so it goes to the body. Okay, so it goes to the body because it defaults into true, because if the condition isn't here, that means the default value will be true, and the body gets executed. In the body, we have the condition if I is less than n. This part gets executed. Let's compile and see again. And if it's greater than n, so So when I is 3, which means that I is greater than 3, we will execute uh, this line, which will break the for loop. See, we get the same output again. So this is some flexibility we have with for loops, that we can construct them whatever the way we like. Okay, so over here, if you take a look at this, so if I like take the condition out, then this for loop will get executed over and over because we don't have a break condition. I don't say break. Uh, no, I don't have the break condition. So if I like remove these if statements and stuff, okay, I think you guys can have an idea what's gonna happen, because I'm not going to break the for loop. It's gonna get executed forever. So it's a infinite for loop. So when we have this when it starts like this, so we create infinite while loops like this in C, or you can use while true as well if you import the right header file for this. So like this, you can create infinite while loops. This is the way you can create an infinite for loop, and within the for loop, you can do stuff like this. Okay, so yeah, so that's one. And then the other thing I want to point out is that you can have multiple what uh, what do you call that thing? Uh, for loop control. So like in here, we call I the for loop controller because it's the one that controls the for loop, whether it terminate when it terminates or not. Uh, it works. Let's check this one out quickly. Works. Okay, so over here, instead of just having I, we can have another value separated by comma. We can say int j equals 0 as well, j 0, 10, or whatever the value you like. All right. You can have multiple uh, values here, and then you can have multiple update values as well. Over here, what I'm going to do is that I'm going to say j is so j is going to get decremented, not I is going to get incremented, j is going to get decremented, and if I print the value j over here, small letter, what's the shit? Expected identifier. Give me a small, quick, give me a small minute. Find out what's wrong. Oh, right. Yeah, small, silly mistake. Let's go to here. Yeah. So over here, you don't have to use I twice, int twice. Sorry, you don't have to initialize it twice because the this in this int initial this int uh, data type applies uh, to both of these. Okay, so that's another point I need to make. I will show it after this one. So yeah, now it compiles and execute. So as you can see, so I starts from 0. It gets incremented one by one. J starts at 10. It gets decremented one by one, and it prints the values. So one thing is that you can only use variables of the same type. So like you can't say something like this. Okay, and you can't like no, that's not what I wanted. So let's say like this one is not allowed because all the values that gets declared over here should be of the same type. So and there should be only one int statement as well. Okay, so this works. So as you can see over here, you can have multiple initializers and you can have multiple update statements as well. All are separated by a command. You can have multiple conditions as well, and you all are probably familiar with that. All you have to do is just separate them with a logical operator. So let's say j is greater than 8. So let's go with 9. So what we're going to do is that we initialize I at 0, j at 10, and I keep getting incremented, j keeps getting decremented. So if I is less than 3 or j is greater than 9, this for loop is gonna get executed. So we take a look at this one. Mhm. Why did it? Oh, right, it used and. Okay. So yeah, if either one of these are true, then the for loop is gonna get executed. So let's use AND operator instead of OR. As a output. Let's execute. Right now, as you can see, it got executed one time and terminated because it got decremented once. And once it got decremented, J was no longer greater than 9. So yeah. So and yeah, that's one. So the last thing I need to point out is you can create a for loop without a body. So I can say int I equals 0, I is less than 1, 2, 3, 4, 5, 6, 7, 8, 9, then I plus plus. Okay, so let's say that I just want to uh like update the value of 5. Right? Okay, so I just want to run this program. That's too much. So let's go up until 1000, otherwise it will take forever. So right now, what I'm going, so over here, what I have is a for loop that doesn't have a body. Okay, you guys will see the use cases later. Right now, just keep in mind that uh, these are some things you can do with for loops. You guys will see the use cases when I do the linked list copy and stuff. Okay, so if I like execute this program, like let's print the value as well, print. Okay, so what it's going to do is that it's gonna start at 0, gonna keep up, increment until 1000, and then gonna print the value. So it should print 999. It should be printed 1000. How did that happen? Uh, okay, that's a small error. That's it. Okay, let's do some good old ChatGPT. Give me a moment. All right, right. So yeah, I has to get updated to 1000 for the for loop to execute. Yeah, again, very same mistake. So what happens is that this keeps getting updated, and the for loop only executes when the i's value is 1000. Okay, if the i's value is 999, so yeah, 999, the for loop will get executed, and it will increment. And once it's 1000, the for loop will execute and print out this line. So it should print out 1000. Right? Yeah, that's a silly mistake actually. So this is a for loop without a body. So as you can see, I declared the I outside the for loop. So what happens if I declare the I inside the for loop? Let's see. So what happens is that I declare the I inside the for loop, and then I'm going to try to access I outside the for loop. So this printf is outside for loop. This for loop doesn't have a body. Okay, so this one is equivalent to this. So like this. You can use this syntax as well, but I prefer to use the semicolon because it's a little bit more concise and easy to understand. So same thing. Okay, over here we have a for loop with an empty body. You can access I inside the body of the for loop without a problem, but when you try to access the I outside the for loop, when the I is declared inside the for loop, you're gonna get some problems. So if I like compile this, I'm gonna get an error I undeclared. That means once it's declared inside a for loop, it's only accessible to you can only access it inside the body. If you want to access it outside the body, you have to declare it outside like this, and then you won't have a problem. Like while I compile this, I don't have a problem. Okay, so it's gonna print out 1000 next time. So yeah, it just gives the value. So that's it. Uh, and then this is the syntax I prefer to use. You can use semicolon or that empty body syntax. Both mean the same thing. That's it. It's a small copy. So you guys will need this when you're when I'm going through the linked list cookies and stuff, which I'm planning to upload pretty soon. So yeah, hopefully this helps. See you guys in the other cookies.